A train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find the acceleration and the distance traveled by the train. So, if you notice clearly, the train is at rest. So if the train is at rest, we need to take initial velocity. U equal to 0 because the train is not moving. And in the problem they are given one more velocity, that is attains a velocity that will become final velocity. Because train initially at rest, after it started to move, it gains a velocity that is given. For us, its final velocity v equal to 72 km per hour. So when we solve the problems, we need to convert this kilometer per hour to meter per second. And we know that conversion, since 1 kilometer per hour equal to 5 by 18 meter per second. By using this conversion, I can write velocity, final velocity v equal to 72 times, in the place of kilometer per hour, I will multiply with 5 by 18 meter per second. So if you can cut that 18 in 72 4 times, therefore final velocity v equal to 520 meter per second. And in the problem they are given time. So time equal to 5 minutes. So this we convert in seconds. 5 times 60 seconds, which equal to 300 seconds, which is t. So from the problem, first I need to find the acceleration. So to find the acceleration, you can use by first equation of motion. So that I can write from first equation of motion, that is v equal to u plus at. How did I chosen that? Because I need to find acceleration. I am having initial velocity value and final velocity value and time. Now we can substitute those values which we are having. So v final velocity equal to 20 meter per second. Initial velocity is 0 and acceleration is given. We need to find, and time is given 300 seconds. Now you can bring this value to this denominator. So 20 meter per second upon 300 second, which equal to a. Now if I can cut 0, 1 0 gets cancelled and the 2 in 30 15 times, I can simply write acceleration a equal to 1 over 15 meter per second square, because these 2 seconds are both in the denominator, they won't cut. So to remove your confusion, I better to mention that as just like this, meter upon second. The seconds in the denominator will become second square. So the final answer is the acceleration of the train equal to 1 over 15 meter per second. Now for the B part of the question, the distance traveled by the train. To calculate the distance, that is second part. For the second part, distance traveled by the train. So that is S value we need to find. And we know the third equation of motion. From the third equation of motion, that is v square minus u square equal to 2as. Why did I chosen this? Because I know the final velocity value, and I know the initial velocity value, and I know the acceleration. Now we can substitute those values. Final velocity, the value of final velocity from here we can get it. So final velocity v equal to 20 meter per second, and acceleration from here we can take that value acceleration, and time, so here we don't need time, but we need the initial velocity u equal to 0. So substitute all these three values and do the simplification. If you can do that, v square equal to 20 meter per second square minus u square, means 0 square, equal to 2 upon 1 over 15 meter per second square times s. We need to calculate s value. So we can do simplification. 20 square, it means 400 meter square upon second square equal to 2 over 15 meter upon second square times s. Here s is the distance. First I can cut this second square, it's easy to. Then 1 meter gets cancelled from the numerator. If I can rewrite, so 400 meter equal to 2 by 15 of s. So you can write the s equal to 400 times 15 upon by 2 meter. Now you can cut. So these two values 200. So the final value equal to s equal to 200 times 15, it gives to me 3000 meter. So the distance traveled by the train. So the distance traveled by the train equal to, so 300 meter. So I got it this value by using third equation of motion.